Oh yeah.
Hi everyone.
I think my audio is broken again.
I can hear you too.
Oh yeah. Am I audible now?
Yes,
Can
and
someone confirm?
I
Oh,
could hear you before as well. Yeah.
okay. Thank you. Yeah, every time I join on this platform, I have to uh click test speaker and microphone. After I do that, it works.
Yeah, that's odd.
So weird. Yeah. Someone from Zoom doesn't like me.
Yeah, it's probably the next OS. Yeah. It's,
Could be.
Hi everyone.
Oh yeah.
let's give it another minute before we get started. Yes. All right. Uh, I see there's quite a few of us right now. Before we get started, I see a new faces in the call. Would you like to introduce yourself? Uh, I see Aditya and I see uh, Pat DK, if I'm pronouncing that correctly. So introduce yourselves. You know, one of you go first. Let's say Aditya, would you like to go first?
Sure. Hey guys. So as you can see, I'm Aditya. I am from Bangalore, India. I'm a software engineer for about 6, 7 years now. I recently joined a startup in Bangalore called Nava, and we've been using Maestro over there. So yeah, I opened up an issue recently about potentially supporting volume encryption, on a per volume basis. So just decided to join in and confirm a few things with you guys today. Nice to see you all.
Hey,
Welcome.
Patrick, I
let's see.
develop all over the place. I'm not particular to anything. I was originally interested in electrical engineering, but computers seem to be the way to control electricity, so I shifted to programming. I was mainly interested in device drivers, things that directly controlled things in my early days. And yeah, so I started at the raw stack level and I've grown to different places, more of a sysadmin these days, and integrations and system implementations.
Hi.
Welcome to the call, Patrick.
Nice to meet you, Patrick. Welcome.
Yeah, welcome.
And I see Shushovan here. He's I know him from going to the office together some time ago. But Shushovan, do you want to introduce yourself?
Hi, yeah. Sushovan here. Mostly I'm having almost like 15 years of experience in RDMA and VME storage, SPDK, DPDK. So I joined recently in data core and started looking after the data plane more closely to uh, introduce some new feature or topic or some performance improvement. Yeah. So yeah, I am mostly in C, C++, but here I'm learning Rust. So yeah, this is me.
Yeah, Shushovan is a smart one. Yeah, that's true. Welcome to the call. Okay, so I'll go as per the agenda today. We have 4 features that we are cooking in the oven, and we would like to, I think, talk about some of them and where we are at with those features. So first one for today is Unmap, and I think Tiago is working on it. I will ask Tiago to talk about it. Tiago, would you are you ready to talk about it?
Yeah, sure. So,
Sure. Go
I
ahead.
mean, just to clarify, I haven't started working on it. For now, it's just it's an OEP for there. It's in there. So please, folks, if you can take a look. I think I've been having some discussions with I think it's Patrick, right? So it's quite interesting, and I'd like to hear some more from his side as well. But for now, maybe I'll just explain what we're trying to do here with this OEP. So we today with MyStar we already support pin provisioning, where you can create a pin provision volume. Initially, it has almost no allocated blocks because it's not written to, and then as you're writing to the volumes, they are getting more and more allocated. So the allocated bytes start to creep up and try and get to the committed amount of data you have for the volume. So far, so good. But let's say you have a volume, let's say it's a file system volume, right? That you have on your WordPress or something like that. And then you decide to delete a whole bunch of data because you want to make up some space in the pool. So you could, of course, delete the volume, and deleting the volume will again free up all the space in the pool. But in certain cases, you don't actually want to delete the volume itself. You just want to delete, let's say, some data that you don't need inside the volume. So in that case, what happens is the file system will free up that data, those inodes. So your file system utilization on your container, on the PVC, is going to look like it's worked. You've deleted a whole bunch of files. You can write new files now. But unfortunately, at the pool layer, we don't really see a difference. So if you wanted to clear up space from one volume to allow another volume to have more space, unfortunately today that is not working. So that is the, let's say, the main reason for tackling unmaps here. There is kind of a second reason, which is if you are using flash devices, flash-based devices, right? We're also not sending any of the unmap or discard commands to the flash storage, which also it's not ideal because you're not giving any slack to the flash to be able to use those pages that you're essentially not using anymore. So I thought of combining two of these things in the same OEP since they are related. And first and foremost, we need the blob store to support and mapping clusters from a single LVOL, which it does already. Unfortunately, at the time that they introduced the support for that, I think there was a few bugs with it. And also, in order to be able to use it, because we have a rebuild that rebuilds from one LVOL to another, we have to be careful that we rebuild the data correctly when there are unmapped clusters. So number one, today the rebuild doesn't propagate the unmaps. So if you even if you were to unmap data from one LVOL, the rebuild is just going to copy everything blindly because it's not very smart in terms of cluster allocation today. So we have to fix that. It gets interesting with the blob store because you can have different cluster sizes. So if you have a different cluster size on the source and on the destination, it also makes things difficult because even if you unallocate a cluster on the source, if the destination is a different size, then you may not be able to actually free the data or deallocate the data on the destination. So I did add something there on what we could do, like calculating an effective, let's say, cluster size, which is the largest. But in practice today, we've actually limited the volume so that all the replicas part of the volume need to have the same cluster size. So at the moment in practice, that won't happen, but it's just more for us to think about it. And it actually becomes more of an issue without the blob store, as maybe Patrick will get to explain. So yeah, the main piece of work here is going to be changing the rebuild so that it reads unallocated clusters, is able to detect unallocated clusters, and then it sends a discard to the remote replica. So it's mostly revolving around sizes of the rebuild, because we used to rebuild in, or we do today, 64 kilobyte segments. But the cluster today by default is 4 megabytes. So we need to either have like a read fill strategy where we keep reading the 64K and then keep checking if it's unmapped. And then if we got a whole cluster, then we send it, or we change the allocation, sorry, the rebuild size to read cluster size at a time in one go. And then, of course, we have the second part, which is to send the discards to the backend storage. So SPDK does have some support, I think, for AIO, where it does use the fallocate punch holes, I think. But it's actually a synchronous operation from my recollection. And one of our old contributors a while back had a commit changing it to an asynchronous operation. But there was a few issues at the time with that code where we weren't sure if it had some bugs. And at the time, we didn't get time to actually go through it. So we just backed that commit out. So that needs to be reintroduced. And
Yeah,
that's
that is true.
pretty
That's one of
much
the
it.
first things I tackled.
Okay, cool. Yeah, so Patrick, maybe you want to maybe tell us about what you're working on, your use case, and what you've done
Well,
so far.
I will, but mine's from a different point of view completely. So
Yeah.
if there's any questions for you, and then I can fill in all the details on the other side.
Yep. Yeah, so I guess I'll open up. Is there any questions on the unmap? Well, one thing
yeah.
I forgot to say, by the way, is that there's another complication, which is from the file system point of view on the top, if it's not sending the discard commands in cluster size units, again, we will not be able to deallocate that from the backend.
Yeah. I have also one pending review on that async unmap support, both in AIO and URI. Maybe can take a look on that part.
Yes. Yep.
So yeah, it's already in the SPDK generate. So basically, I have seen that one guy from community already reviewed it and one posted one comment.
Oh,
Anyway,
nice.
yeah.
Nice.
Uh, yeah, I listened this part carefully. So one follow-up question. So let's say you correctly mentioned, like, let's say today, if my volume is having, let's say, 70% of the old checkpoint data that we are not using it, and they want to zero it out or they want to clear it, right? So now, don't you think that we should have a mechanism to detect the access frequency automatically, and at least ready the candidates that that are not accessing, let's say, past few months or so. I mean, it's like really like very cold data, and automatically detect those and put those into some sort of cold pool, or a pool consists of HDD or very cheap drive, and free up the space. That can bring some intelligence. It's called storage tiering. In case, or at least identify those candidates. I mean, then maybe display those zones of cold data, so that user can eventually decide whether to move it in the cold storage or cold pool, or eventually delete it, right?
Yeah. Yeah, I think that is something we'll need down the line, but I think the problem today is that we don't really have a pool, right? We call it a pool, but it's a single disk. So I think probably first we need to tackle actually making the pool a pool and having multiple disks. And then once we have multiple disks on the pool, then we can start doing those tiering operations and detecting the hot and cold clusters.
Yeah,
But
right.
today, I think that with a single disk, there's not much we can do, or we would have to put that above the pool. But then,
it's over it. It's over it for today's case. Yeah.
Thiago, I have one question on that unmap. So some storage solutions basically they have this intelligence where let's say if they have IOs, production IOs running on that pool, they will delay the unmap because that's also an IO load on that device, right? So I think VMware or somewhere they have these policies like aggressively reclaim the space or do it at times when there's no IO, or do it very slowly over a period of time so that it doesn't put too much IO pressure on that device. So this thing also we should look down the line maybe.
That's not something we actually have to deal with. That would be a pass through. We would pass that through to the end client, and that would be handled by the application layer. Not, it would just go through the stack, the OpenEBS stack.
Okay. Yeah.
Yeah, the only trick there is when we specify the max amount of, I forget what it was, max blocks that you can erase at a time. If you don't specify it, which is where it's at now because it hasn't been implemented yet, it's at 2 TB. But normally you limit that to like 32 megabytes or something like that, so that you can't get those huge blocks being erased at one time. And that would happen
Yeah,
all the way at the top level.
yeah, that could be one thing. Yeah, I mean, I just wanted to know, like, this could be a future thing where uh, we also look at this point, like how frequently the space is being reclaimed.
Yeah, we might need to think about how to handle that. If we rely purely on the applications, or rather in many cases it won't be the applications themselves. Well, it depends on the application, I guess. But if it's just an application using a regular file system, it will be up to for example, the fstream file system running on the hosts. But that might be harder to configure if you have a whole bunch of hosts, and then if they suddenly all decide to run the fstream service at the same time, right?
Okay.
So maybe
Yeah,
that could be something we could do. In terms of the blob store, probably doesn't matter all that much because it's just the blob store itself is just the most important thing is reclaiming the clusters. But then if it also sends the command to the backend, then yes, potentially we could have a whole lot of trims being
yeah,
sent
yeah.
to,
This is
to
specifically for, I mean, the shared pool application, like the application sharing the same pool. It's a problem for that.
yeah.
Yeah.
I'm not sure if I did any work to serialize it to a single device or not. I know I was restricting the sizes and splitting them out so that we didn't send overly large downstream.
Yeah. Yeah, I
Um,
think I remember there was also some bug in the SPDK where it sent very large. It
yeah,
allowed very large discards.
I split that out and I split it out so that there was an individual. When the request to unmap comes in, it doesn't stay serialized in line until it's done. It gets split out and that's processed in the background while it
Yeah,
continues on with its normal duties.
yeah,
Yeah, I was not concerned about blog store because I was not interested in blog store from an unmap perspective or really at all.
yeah, because
My
you're
goal,
skipping. Yeah,
yeah, I'm just gonna go right into the why I'm tackling this from a different point of view, which is kind of unrelated to how the project is dealing with things currently. But I was interested in implementing a ZFS backend for Z volumes to be served for my actual volumes as my base because I've been using ZFS since 2010 and I've been very comfortable. I dump my NetApp arrays and systems for ZFS and it's been an improvement in the data guarantees I get from it. I really enjoy. Um, so I was interested in implementing ZBall um, for the backend store instead of the blob stores. And for that, I needed thin support, and that means I had to deal with Unmap and getting trim working across the stack. Um, Fortunately, the LVM work that's in the tree, well, it wasn't plumbed and connected. There was plenty of it for me to base my ZFS work on. And
no, I'm glad because that was the original intent. Is that there was another
yeah, my
community
ZFS works
person.
bridged the
Yeah,
gap for that to actually work, but I didn't go in and
yeah,
fix LVM's issues. It
yeah,
doesn't have any snapshot support, doesn't have any encryption
yes,
support,
that's correct.
um, which I never looked at, and I didn't realize it even didn't have that support until like yesterday. when I was looking at to see what gaps it had, because ZFS does it differently. So I wasn't even looking at how LVM handled that because it wasn't relevant at all. And LVM thick is different from thin. LVM thin works the way we would
Yeah.
expect it to, the same as like Bob's store or ZFS works in thinner thick mode. But LVM thick mode directly passes those along to the storage device. So whatever we do for unmap is whatever the device is actually doing. It's not imitated. And that only matters for one use case, and that is with Blob Store, we know if we, unlike what you were saying, how to deal with replication and all that, that is a kind of solved issue for me because I don't have a choice. If we were using real devices and we did an unmap, we have no guarantee that the unmapped data is read back in a consistent way. It's whatever the device wants to give you. It could be zeros, it could be random data, you don't know. The guarantee that it would be zeros was discarded long ago due to it just caused too much extra work for the devices to deal with. ZFS and LBM thins guarantee you get return zeros, just like Blob Store. LBM thick does not guarantee that because it goes directly to the device. My ideas was, and it works for Lobster too. So when I saw the EOP about Lobster, it became that's a small addition to what I was handling because everything else I had already handled. But instead of doing an unmap, we're effectively doing a write zeros everywhere. And if the underlying device supports unmap, like ZFS, DVOL, or LVM, thin volume, or blob store, it just becomes a unmap command because we know we're getting a zero coming back when we read it. And if it does not support it, if we have a thick ZVOL, that becomes an issue. But we can say that we just don't support thick LVMs. We can say it's thick, we can just write zeros instead and just handle it that way. But there's not really any good way to handle the replication issue unless we actually write zeros there. The best we can do in that case is do a test unmap and see if we get zeros back. And if we do, we can assume that it supports returning zeros on unmaps, and if we get random data, then we assume it doesn't work and we have to write zeros.
I think that might be tricky though, because it might return zeros and then it might not.
Yeah, if somebody, I mean, yeah, it depends on the device. It depends if someone changed out the NVMe drive later on a different date, or it gets really iffy.
Yeah.
But it's that's the best we can do. I see. For the replication side of things, I was taking it from a different point of view. I was assuming we don't care about the granularity of the unmaps. That's a issue for the receiver to deal with. The sender just detects where the zeros are and sends that we have zeros for this long at this position. It might care about where, as far as a page size, where the zeros start, but that would purely be an optimization for detecting it quicker and not being so fine-grained about it. But the sender, I would not say should have to deal with trying to figure out the block sizes and where they line up and all that. That should be something the receiver says, it lines up with what I'm configured for and what I can deal with. We will unmap that. The only issues are, and I haven't dealt with this because this is kind of where I stopped, I implemented the unmaps and checked and made it work from a single replica standard point of view. But then when I was going to multiple replicas, um, I had not tackled that yet. I paused my work. I found the EOP, talked about it, and I was looking for feedback on before the protocols start getting adjusted and things that actually matters outside of my ZFS space, things that touch other systems for guidance before I start going wild there. But my idea was to replicate the holes, not try to conform it to blocks, let the receiver conform it to blocks, and either set a static size block that goes upstream and it just says whether we say 4K, 16K, 4 megs is what our unmapped size is, and upstream, that's what they feed us, and we deal with handling different size downstream at each destination like the replica would do it. But yeah, my thoughts, I hadn't implemented that, so my thoughts aren't fleshed out and the edge cases all handled because I stopped work at that point because I'm touching things that would affect more than just my goals of ZFS.
Yeah, I think on the allocation size, probably the control plane can just kind of do that work where it knows the allocation units of each replica. So it's able to just tell the Nexus, this is a 4 megabyte cluster replica, and then the Nexus can then figure out, how I should size the allocation. But I think I also wrote on the OEP that potentially another way could be to kind of do it lazily. And I think some storage systems do that, where we would have on the timer some thread that would just start reading the disk. And then if it finds all zeros, then it could send an unmap. Things like that. But there is a cost of doing that. Because if we write zeros, then we know that if we write zeros, if we find unmapped regions, then they might not be unmapped, but they will be zeroed out, so we can detect those. And then each local device can do that by itself. Well, not on device, of course, on the MyStar code running locally. It can lock ranges by cluster size, read if it's zeros, send unmap. But of course, again, it's the same thing where you have you have to schedule that work when there's not much activity on those on the system. But it's possible. But yeah, it's great. I think as I was saying, so initially there was some work done by the community on LVM, and then I kind of tidied it up a bit because there was someone else on the community saying they wanted to use EFS. So I tried to make kind of the LVM a proof of concept that could be used, but then I stopped there. I never worked on the snapshots and all that. So that's why that never ended up getting into a working state.
Yeah, the LVM is not a big project, especially after adding the ZFS.
Yeah.
The unmap is the issue for me, and it's turning into a lot larger project than it seemed like it should be, but it really is something that has to be handled with care.
Yeah. Yeah. Any questions from anyone on the work Patrick is doing?
I'll review the OAPPR. I don't have a lot of context. Yeah, no questions.
Yeah, Patrick, if you don't mind, maybe at some point you could create an OEP for adding ZFS support or ZFS-LDN.
I have one I drafted, but I did not submit it. I'm in the position that I didn't want to just flood everything, especially I want to get a gauge on feelings before I started really throwing things at.
Yeah, sure. Yeah, that's your own time whenever you think you're ready for that. And then, yeah, it'd be great to see. It's really cool.
And like I said earlier, the unmapped thing was it was a second stage for me for the ZFS work. Was required for my ZFS work, and I did not handle replication stuff because that was a third stage, and I wanted
Yeah.
feedback before I went there. But yeah, I wanted to see if we can get the unmapped stuff resolved, and then I can move along with the ZFS.
Yeah, makes sense. All right, thank you. So
I think we have a few more. We could take the smart one. I think the smart is like one of the big ticket items. In fact, all of them are big ticket items. But Shushovan, do you want to talk about the smart OEP, smart metrics?
Yeah, sure. Yeah. So the idea here is so far in Mayastore IO engine, we don't support as of today the smart data for the disk behind the pool. So and the problem for that is let's say we don't get to know the live status or the live health of those disk. Let's say if they have any media error or any in-transit error, the temperature issue, unsafe shutdown, critical warning, all those typical the smart information, the current snapshot of the drive, right? So the idea here is to get those information like sort of pool health. So right now the pool consists of the disk, and when we get to know the pool health, so it's a disk health underneath the pool, right? So the idea is like so we mostly we're gonna use the smart monitor tools to get those smart informations, and also some vendor specific information for that drive, the current status, right? And the drive, like NVMe drive, which is offloaded from kernel, mostly this VFIO stuff, that we're gonna use the get log page, right, and collect those smart data for the drives and available to the gRPC. So now the next, so this part probably currently I'm working on. And as a next, as an extended part of it, like we in the control path, we should have a logic that will consolidate those data, right, and take any uh, uh, advanced precaution. Like let's say if the drive health is degraded, or we came to know about the drive is having some media errors or critical temperature issues, etc. Right? So uh, we can take some smart decision that we don't send replica on those drive or something like that. I mean, it's a decision that we need to, the decision engine is not yet built. But currently I'm working on at least those in the data plane side, at least those informations will make it available in the per pool basis, right? So that is the work currently I'm doing. There is a WP out for that. Yeah, go and take a look what all I'm covering on those part as of now. Yeah, that's it. I mean, it's just like a current health of a drive, and periodically we'll get it as a pool health. Yeah. Any question on that part?
Nope, sounds good. Yep.
Yeah.
Thanks.
Okay.
Could we expose that information via something that could be consumable in a Grafana dashboard or something?
So then we need to. So basically, I don't think it's gonna be a problem because as of today, those information are till the gRPC. Those information are available. So I think it just, if we can just have a REST API to take those from there. So at least not the entire logic, but at least those information we can make it available in the REST, right?
Or maybe
Yeah,
don't need the REST as well. The metrics exporter could just export it via
the
the
metrics
gRPC.
exporter.
Yeah.
Yes. Yes,
Via
the
the
metrics
host API, right?
exporter.
The block devices API,
Yes.
you see.
Okay.
That should be straightforward, I think. Yeah.
Yeah, the
But
metrics exporter could just call the smart API instead of the host block,
Right.
and then
Yeah.
expose that information, and then we can connect that to Grafana, and then or even Prometheus alerting and whatnot. So if there's any critical errors with a drive, we can have the alert manager configured to send an alert, etc.
Yeah. Yeah, critical warning or media error or temperature trace. Mostly like the at least 4 or 5 field, which is very crucial for a drive health, at least to just yeah.
Yeah.
So we should also probably check whether this smart information is already being exposed via the Prometheus node exporter or any other thing, so that I mean it's not a rework or something. Let's say, like, do we already have dashboards for smart?
We wrote our own exporter, right, Krishna? Which
Yeah.
runs on the IO engine. So
Yeah,
I
but
think
anyway, those details about the disk should be displayed, right? So,
I think that's what Shobhan
this
is.
could only relate to pool, right? But
So there would be two things to watch out for there. One is we would have to map the disk to the pool. But then the biggest killer there is that if we're using VFIO to talk to a device, right, node exporter is not going to be able to get that information.
okay. Yeah.
Because it's not a kernel block device at that point. So we have to export that.
Okay. Yeah, that makes sense.
But for the standard AI or Turing based pools, we should just be able to call the gRPC endpoint of smart service. That will be there in the IO engine, and
No, for everything that will work, right? The endpoint is exposing everything. What I was saying was for what Krishna meant, if there's any standard way that is, if there's already a node exporter
Oh, okay.
for smart data disks, right? But that will not cover the VFIO pools because those are, it's not a kernel block device at that point. So
Yeah.
but yeah,
Would be like
maybe so if you could also briefly mention this on the OEP, just so we don't forget. I think
Yeah,
this would be quite useful to expose.
Yeah.
Yeah.
Okay.
Yeah, I'm going to pause here on the features. I recall Aditya wanting to ask his questions. I'm just going to open it up to him. Yeah, Aditya, do you have something that you wanted to discuss specifically? With
Yes, I
respect to
just wanted to confirm a few things on issue 2027, which is relating to per volume encryption. So this discussion has been ongoing for a couple of weeks now, and I haven't filed the OEP yet, but I'll make it provisional this week. My question essentially is, we kind of decided on placing encryption at the nexus rather than at the LVOL. Now, that being said, is there any path that's known to you guys where somebody accesses the underlying disk outside of the nexus?
You mean underlying replica?
Yes, yes.
I don't think
So
that's a trivial use case. Yeah, go on, Diego.
yeah, so there's a piece of work that I ended up pausing, unfortunately, but it's I think it even started before the OEP process was in place. So there might not be one. I'll create one, which is the snapshot chain rebuild. We just to rebuild when you rebuild a replica today, it doesn't rebuild the snapshots. It only rebuilds the current version, if you will. But there's already some code and some APIs that let you basically rebuild a snapshot from one pool to another. And then in that case, we actually copy the data from the replica directly. But I don't think that would be an issue because at that point, we're not serving that to a host, we're just copying data. So we don't care if it's encrypted or not.
Yeah, that should not be a problem, ideally. Yeah.
So the only place it could potentially matter is above the nexus, which is fine, right?
Yes. Yes.
Okay. Okay, cool. And another thing I wanted to ask,
There is one catch potential. No, I guess that's not a catch. Yeah, no, never mind. Yeah, go ahead.
okay. The other thing I wanted to ask was, just give me a second. So we're also confirming that we're not doing a volume attribute class, right? We're keeping this at the PVC itself.
So that's putting the metadata, sorry, the annotations on the
Yes.
PVC, right?
Yes.
Yeah, I guess I'm fine with that. I think other storage
Or is
solutions
that
do
for
that
the
as well.
secret names, right? Is that the one?
Sorry?
For getting the secret names, right? Is that the one?
Yes,
Yes.
yes. Someone had suggested going with volume attribute class. That's why I asked.
All right, I see.
It's not required. Volume attribute class is mainly used if you want to modify it in a later stage.
Yeah, I
Um,
mean, if you want to modify any storage class parameter, right? But in this
right.
case, the key won't change, right? So it's fine.
Yeah,
Uh,
fine for this feature.
yeah.
Okay, cool. I think it would make sense only if SPDK supported some rekey or something like that, but I don't think it
No, it doesn't, I
supports that.
think. Yeah, it doesn't. It doesn't.
So
Okay,
yeah,
sorry, go
I
ahead.
had a question here, which is, so is the intent here that every volume would get a different encryption key than the other one, or how do I explain myself? Um, so so there's probably two paths, and I've seen storage solutions do two different ways, right? One is you actually create separate encryption keys for each volume that you have to manage. Another way is that you could use, let's say, different salts and different salts depending on the offset as well. So, and if you do it that way, and you encrypt and you store this configuration on the pool itself, you actually have guarantees that each volume, one volume write compared to the other volume write, will not be the same. Right? So a user will not be able to kind of infer the contents of another volume based on its own data. So I'm just trying to ask, like, what is the main objective of having these separate secrets per volume? And do we necessarily have to have that, or could we use some other approach using salts that would avoid having us to, actually keep a separate secret entirely for each replica?
So the driver for this was essentially to give each tenant isolated encryption on volumes they own. So if somebody wants to get rid of something, it should be as simple as destroying their key. And I don't think we'd be able to do that with what you just suggested, right? I'm not sure.
We would. So there's two things here. One is you could, on the pool, it could have, for example, a table of volume encryption keys, which would be derived from the full encryption key, for example, plus a salt. So that means that effectively each volume's data is actually slightly different. And some storage solutions actually take this a step forward, and even depending on the offset, for example, the data is also different. So it means one volume cannot actually, using one volume, you cannot try and guess the data of a different volume unless you get the pool encryption key. So I guess that's the main question. Like, is it because you don't want the same pool encryption key? Because if you do it on the pool and you have the pool encryption key, then of course you would have everything. But if the intent is just to make sure that you can just delete one volume very easily and the data cannot be read again, then you don't actually need separate keys per volume. You just need to do this salting.
Okay. I guess that could also work because as long as destroying the key makes it inaccessible, that's the only thing that matters.
Okay. So yeah, I guess that's something to think about. And also, I had another thought in relation to the nmaps, actually, which is if we put the encryption above the replicas, unmapping is not going to work anymore, because the data you're writing to the pool is already encrypted. So zeros are not zeros anymore, and that kind of thing. So I don't know if you've thought about that being an issue or not?
I have not considered that actually. Hmm.
Because if that is an issue, then I guess you would have to put it below the blob store still, or not below because you can't. I guess it would have to be done inside the blob store somehow.
But
That
will
becomes a big issue. I mean, you can take the caveat of you can't unmap encryption, and that would be a feasible defense to say, because if you can unmap something that's encrypted, then you know where there is and is not data, which defeats some point of the encryption itself.
So correct me if I'm wrong. I'm not sure if I'm making sense here, but wouldn't that mean you're giving away information on whether something is claimed or unclaimed space? Should that
Yes.
even be a factor when you've encrypted?
You're giving away.
I think that depends on the user. If the goal is to denial of data existence, or they want to be able to be friendly to their storage and not have data publicly readable. I mean, it comes down to what security standard you're trying to meet.
Yeah. It also depends on what you're trying to secure. Is it just data at rest so that if someone steals the disk, right? Or
Yep,
are you
so
trying
it's plausible
to do
deniability.
something?
Yeah.
Yeah.
So from the data layout perspective, so is it like if you have mix of encrypted and unencrypted volumes in a non-encrypted pool, so does that mean the clusters claimed by the encrypted volume, they will have the ciphered data, and the others will have plain text? Like the non-encrypted volume will have plain text, right?
On the
So that's
proposed
That's what
approach,
I believe.
yes, I think so.
Yeah,
Yeah,
that
sorry,
will
go ahead.
be it.
Yeah. So how do you think we should move forward with this now?
Also, like how are you planning to manage the scale of secrets? There will be a lot of secrets, right? I believe.
Yeah, so I was thinking the secrets could be managed as a PVC annotation, or the reference to those could be stored at the PVC level.
No, I mean the secret objects by themselves.
As in, what do you mean?
The Kubernetes secret object. There will be a lot of them, right? Or like, how do you manage them? Do you have a KMS or something like that?
Yeah, I think this will have to be backed by a KMS from the user side.
I mean, for a pool, it kind of makes sense. But for a volumes might come up and go. So there will be a lot of secrets. So there, the secrets life cycle also needs to be managed with the volumes life cycle, if you see what I mean, right?
Yeah, some
So
sort of secret provider will need to
yeah, yeah, okay.
dispatch and manage these.
Okay.
There was also one more question on what if a user opts in for pool level as well as volume level encryption, assuming this feature exists. And to that, I think the only place where both of these information is available will be at CSI create volume. That's at that point, from the SC parameters as well as the PVC annotations, and you can reject it there maybe or something like that.
I think you can reject from the control plane only, because if you have to do it from the CSI, then you need to do a get pool, one more call to the rest to see if the pool is encrypted already, on which they are trying to. Oh, you mean, sorry. Yeah, I guess, yeah, CSI only. It's there in the spec itself, right? If they want a pool level encryption.
No, hold on.
Yes.
I did not understand the question. How are you defining there? The volume replica placement is afterwards, right? It depends on the scheduling.
Uh,
Um,
the storage class only, I think encrypt true means pool level encryption.
Yes.
So if they have specified PVC annotation also, requesting for a volume level encryption, and in the storage class also, if encrypt is true, then it means that the intent is to encrypt at both places.
Probably you can take precedence on the pool. I mean, okay, it depends. So, yeah.
No, because what they want is
Yeah.
a user should be able to delete the encryption key, right? And then the
I
data
see.
cannot be read again. So they cannot rely on the pool one. Yes, I would say that we have two options, kind of the soft and hard. So the soft is saying, we're gonna do encryption at the replica layer. We'll try and prefer pools which aren't already encrypted, so that you don't pay the penalty twice.
Yeah.
And then if we can't, we'll just give you whatever we've got. Then there's the hard options where you say, I only want replica encryption. Don't put me on pools that are encrypted.
Can't we just reject it? Let user specify, like pool or.
No, it's not that simple. A volume creation it may be, but then what about rebuilds and all? So that this has to be a user setting that it has to tell us what is okay to do, right? Because if we have to do a rebuild and we have to pick another pool, and then we'll have that same question, but this time we can't just reject it to the user, right? We're gonna have to make a decision.
No, I meant user from their spec only will tell either pool level encryption or volume level encryption. They can't specify both. Then we just use
No,
that.
but
We want to do a
no, but
rebuild.
no, but during the rebuild, what if you have pools that have encryption and pools that don't have encryption, but for
Yeah.
some reason at that particular time you only have pools that are already encrypted? Then what do you do?
I think the same issue happens now also, right? It's applicable in the current
No,
product.
no,
If-
no. Right now it's hard. If you
But
want encryption, you'll get encrypted pools. If you
yeah,
don't
it's
have
right.
encrypted pools, then you should have created
It's a
them.
hard requirement now. We will not
Yes.
provision without an encrypted pool.
Yes, that's what I mean.
Same
It's
applies.
soft and hard, right?
If it's a pool level encryption they have specified, then it's kind of hard only, right? But on the volume level encryption, I guess, yeah, it's only going to be an unencrypted pool, right? We are not going to place it on encrypted pool if it's a volume level requirement, encryption requirement.
Well, we could, because so the problem with just the encrypted pools is that if you don't put it on, let's say what we have today, encrypted true false. If you say encrypted true, you cannot put it on an unencrypted pool because you are basically not respecting the user request of having encryption. right? It's a security issue. Here, it's a
Yes.
performance issue. If it goes on the pool which is not encrypted, perfect. But if it goes on the pool which is already encrypted, you're paying for the encryption cost twice, right?
But Tiago, if they've asked for pool level encryption, you can't put it on a non-encrypted pool, right? Because the user has asked for it. I think yeah.
This is when the user asks for the volume level encryption. Then what do you do in that case? If the pool
Then
asks for pool level encryption, then no problem. We'll just give
yeah,
them the pool level
only pool.
encryption without the volume. Yeah.
Yeah.
The issue is when the user asks for volume encryption, but then
Then
during the rebuild, we don't have any pools without encryption. So they're all encrypted at the pool level. So
in
what
that
do
case,
we
I think
actually do at that stage?
they need to create a pool. Like that's what we do now also, right? If it's an unencrypted volume, right now it's only pool level encryption. We suggest user to have enough pools which are encrypted if the rebuild is required. So similarly, in that scenario also, if it's a volume level encryption, and if you're thinking that we won't put it on a encrypted pool, then they have to
No,
have.
Abhilash, that mode needs to be enabled on code agents explicitly if you want to do that. It's not there is a flag that you need to set if you want to do that. The
Like
mixture
half
of for migration or whatever, right?
Yeah, that was explicitly for migration.
Yeah.
No, I mean that if they are lacking pools, which are, for example, if it's a volume level encryption, and if we decide in our implementation that only unencrypted pools needs to be used for scheduling, then if ever a scenario comes where rebuild is required, then they need to have unencrypted pool in their cluster. Otherwise, we will just try for looking up on the candidates. We'll just similarly how we do now. Like if you're not able to find a pool, we'll just try to find a pool. Then they can create a.
Yeah, but this scenario is different, right? Because on the scenario just for the pool encryption, if we find a pool, we will not be respecting the security, right? Because it will not be encrypted. In this case, we can. It's just that the performance will be slower if there's no other pool available, right? So that's why it's a question of deciding whether we want it to be soft or hard.
Yeah.
So for encrypted pools, it has to be hard, because if the user says, I want an encrypted pool, then you should get one. But in this case, if the user says, I want an encrypted volume, then maybe you should also be able to tell us whether he wants it to be soft in terms of the pool placement or hard. So hard being only use unencrypted pools because I don't want to pay the performance penalty, or use whatever pool you've got. Of course, prefer unencrypted, but if you're running out of pools, then I'd rather be safe than performant, right?
Will that apply on the creation also? Like at the
Yeah,
start.
that should apply. That
Yeah,
should probably apply on the
create pattern,
creation.
right?
Yeah.
I might be missing something on that, but it seems redundant to me. If the user wants the volume to be on an encrypted pool, wouldn't they just set the requires encrypted pool property? There shouldn't be a need to specify this volume must be encrypted on top of that, or instead of that.
My one more question is there any extra security that you're getting? Anyway, the data is written in ciphered way only, right?
It's not
On the
about
device.
security. It's one level of encryption already gives you the security. It's twice the encryption will get you into a performance penalty. So that's the issue, right?
That is a problem only. Just because you have more access to a lot of you have more pools available, would user want that?
So I mean that's what the policy is for, right? They decide what they want. Um, I mean, obviously we can play it simple and just reject it outright, uh, but consider there won't be like adding a new pool always is not a good solution. We have seen users uh, who will not be able to add a new pool because let's say they do not have a new node. Because right, replicas needs to be on different nodes. So there are a lot of restrictions here. You will have to consider that as well. So yeah.
You have some replicas with a different level of security. Some would be a more, I mean, double encryption, if you will. Don't know. Um,
I mean, since the goal is essentially key ownership and, whoever might want this for compliance or whatever that might be, I guess the question is whether you guys want to support the user to use it in a non-optimal way or not. I mean, we can reject
Yeah.
it. That is the easy solution. But if somebody wants to use the tool in a suboptimal way, then I guess we can support that with that hard and soft and prefer uh, hard approach or the other thing that he spoke about.
Yeah.
Patrick, you were saying something. We just missed you out there.
Yeah, I was just am my voice working? I'm not sure.
Yes, it's working.
Yeah,
Okay.
I can hear you now. Yeah.
It's not giving me any feedback. I was saying the reason the user specifying volume must be encrypted, it seems like there was a choice there. It's not a binary yes and no. It sounds like this volume needs to be encrypted. This volume needs to be encrypted with my specified key, or this volume does not need to be encrypted. And it seems like volume needs to be encrypted. That's a pool level. It doesn't have to be specific. But if the user says this volume needs to be encrypted with my key, then it's how it's dealt with by OpenEBS. Either we put this, I don't think it really matters what pool it goes on, encrypted or unencrypted, because the volume is going to have to be encrypted itself anyways. I think
True. Yeah.
some of this discussion becomes moot because that's not something that we can decide.
It just as Stia was saying, right? Just about the optimal way or non-optimal way, right? Um, that's
Yeah,
the
but I
issue
don't
here.
think that's something that we can decide. That's something that the user has to say. I mean,
Yeah.
they're going to say, I want
Yeah.
this volume encrypted. It's data at rest encryption only. It's not that this volume must be encrypted separately from everything else that has to be encrypted.
Yeah.
Whereas sometimes this volume must be encrypted and has to be encrypted separately. And at that point, it doesn't matter what pool we throw it on because that volume is going to be encrypted itself.
Yeah, it's just a question of the performance penalty, because if you put your per volume encryption on a pool which is already encrypted, then you're kind of paying twice. So instead of, let's say, worst case with large writes, you get maybe 40% performance penalty. Just making up numbers, I can't remember what it is. If you do it twice, then
It's
you're going
40%,
down
I think.
to, yeah.
Yeah.
So you're going down to a very small percentage, whereas if we place it on pools which are not encrypted at the bottom, then you're only paying once.
So it can be
Yeah.
like this also, right? Like preferred non-encrypted, and if there's nothing,
Yes.
go for the encrypted.
So we'll
Yeah.
default to
So
non-encrypted.
yes. Yeah. So
Yeah,
that's
default
what
to
I
the
meant
soft.
by soft or
Yeah,
hard, right?
default to the soft mode. Because
Yeah.
that's fine. Yeah.
Yeah.
And this choice will be on the pool encryption, right?
No, this will be on
Well,
volume, right?
Volume encryption.
Still on the volume, right?
yes.
Yeah.
On the volume. Okay.
Yeah,
And it solve your unmap problem.
Sorry?
Does it
Your
solve
unmap
the unmap problem? I
unmap
think he
problem.
said.
What solves the nmap problem?
No, you said that so the 0 is not 0 anymore, right? So when you let's say the write zeros
Yeah.
on a volume which is encrypted.
Yeah. Yeah.
So that problem is still open, right?
Oh yeah,
Previous one.
yeah. No,
Yeah, that's still there.
that problem is still there. However, you want to handle it. If you're fine with not having, any write zeros or unmaps, then I guess it's fine.
I would leave that as a note in documentation. If you're going to encrypt at the volume level, unmaps will not work due to security.
How about that? So SPDK can expose a crypto VDEP, right?
Yeah,
Yes.
virtual crypto. Yeah.
VDEP crypto.
Yeah, it's a virtual BDEF that is created on top of the BDEF. That is the crypto
Yeah.
BDEF. Yeah.
Yeah, that's how
And
we're currently doing it.
Yeah.
okay.
Okay.
Yeah, I guess my question was more like if we put that encryption above the pool, then yeah, you will miss out on all the write zeros and
Unmap. Yeah.
Yeah, because the data will be encrypted once it reaches the blob star.
Does unmap work on L1 layer or pool layer? Why I ask, because if it works on pool, then no matter where we are doing encryption, you have zeros. I mean non-zeros, right? If it is zero also, if it is writing zeros also, it will be ciphered into something else on the actual like pool bidder. So my question is how unmap works if it is pool encrypted volume, and it doesn't work if it's a volume encrypted volume. I mean, yeah.
Because at the pool, it's done below the blob star. So you will be able to issue an unmap or write zeros against the blob star, and the blob star will know that it's. Or if you do the other way, where we have a thread that reads the LVOLs, right, and search for zero, they will read zeros. But if you put the encryption above that, then you would not be able to read the replica and hope to get, read zero so you could unmap it, because that data is already encrypted.
Necessity.
Not sure it matters as much, because if I haven't looked at decryption too much yet, but is the encryption's happening at the SPDK level?
It depends where you place the crypto bidder.
I don't mean the pool, I mean for volume.
Oh, per volume, I think there's two options that we discussed, which was one, to put it above the blobstar LVOL on each node, and the other option was to put it above the nexus. As in on the nexus BDEF. Yeah, above the nexus, I guess.
Because if the SPDK gets the command, if it's just getting data that's already encrypted, it's not going to work. But if it's getting the unmap command at that level, the unmap command is just going to issue all the way down the stack, and it's going to create a home. But if it's already encrypted at that point, then yeah, it's just going to be writing random data.
Yes. I think if it goes above the nexus, then it would be encrypted at that point. I guess we could put it. Maybe that's an
like I was
advantage
saying
of
earlier, that's a
having it on the
different.
replicas then.
Well,
Yeah.
you put it's a question for the user because do they need the holes encrypted or not? That's a different question.
Yes. Yeah, I would say probably let's create an OEP and maybe carry on discussions there. Yeah, I'll need to have a think for it.
Yeah, it will be good to follow up there. Yeah.
Yeah.
Okay, then I'll open that this week and I'll update whatever we sort of confirmed today. And yeah, we'll continue this discussion there. Thanks, guys.
Yeah, but interesting stuff. It's nice to have a discussion on this. Yeah, thank you. Okay, I think we're almost up on time now. I think we had a couple of other topics. So we might have time for one more if it's quick. Otherwise, I would say leave it for next month's meeting, but I'll leave it up to you if someone wants to bring something really quick. We have 9 minutes.
Do we want to talk about the pool drain feature, Abhilash? What do you think?
Yeah.
Or we could talk
You,
about
you
it.
have 9 minutes though.
Yeah. I'll be quick. So, or you were saying something, Niladri?
Or you could talk about it next month, or possibly after release. It's all the same. Yeah.
I'll try to give like a brief information about it.
Go
So
for it.
right now we have everything set up to drain a pool, but we don't have the utility to drain the pool. So what it does is basically it allows user to evacuate all the resources from the pool. If user wants to service a particular disk, they can just drain that pool, issue a drain command, which will evacuate all the replicas created on it. The phase one of this feature just targets volume replicas. The phase two, after the snapshot rebuild is implemented, will cater the snapshots also present. What it does is that right now it's not stitched to the node drain, but eventually if user wants to take out a node from the cluster, they can eventually use node drain command that will serially drain all the pools in the cluster. This feature has other functionalities also, like it limits number of concurrent drains. It limits number of concurrent volumes draining from the from the pool. So yeah, as I said, it drains all the volume replicas now, and in the upcoming phases we will thing also. Right now, for the snapshot, what we do is as an option to drain only replicas. If they don't snapshots on other replicas of the volume, they can go let away the snapshot. Then they can use accept snapshot loss. Once the replicas are moved successfully, we destroy the snapshots present. That will put a pool into a drain state. Yeah, I guess that's it. Is there any question on this? The OEP is open, so please have a look. one PR of the OEP is already must. I've created one more PR which marks the OEP as implementable with some more changes. Yeah.
You are 5 minutes ahead.
So I had 9 minutes. Started on 8:51. Yeah.
Any questions on the drain?
No. Yeah.
Going once, going twice. Okay, go. Then that's a wrap. We can close off. I suppose the longest meeting we've had on the community front. Yeah, interesting one. See you next month.
Yep.
Bye.
All right. Thanks everyone for joining. Bye. Let's drain the meeting now.
Bye.
Thanks, everyone.